This is a video demonstration on how to script for configurable joints. One of the reasons why some have wanted to do this, as well as me, is for creating physically based character animations. This table here is rigged with hinge joints that allows me to move the legs with the mouse. As you can see, I'm moving the mouse back and forth, and the legs are moving. There's no character animation in this. This is moving strictly through physics. Not very good, but it works. However, the hinge joints are not the best to use. You'd have to use many of them for what just one configurable joint can do. Let's get rid of him. And let's bring in our beams for this demonstration. These are the three beams. These two here are already set up with, as you can see here, they're set up with hinge joints, each in a slightly different direction, each with a spring of 50. And this one here has got our configurable joint. This game object here will be holding our scripts that we will be attaching these objects to and controlling them with the mouse, just as we had the table. Now we will need to assign these objects to these scripts. Now these two scripts, they do the same exact thing, but they're written differently. This one here is asking for a hinge joint, where this one here is asking for a game object. We'll move these two objects over, and as you can see here, it's taken the hinge joint from beam 1, and this here is taken beam 2 as just an object. We'll need to set up this script and this script with this object, beams 3. As you can see here, I've set this here up for configurable joint and rigid body, but in this one here, it will only call for the game object. It will create the beam, it will call for the beam and the rigid body within this script. Now the rigid body is actually very important, and I will explain why. But first, to show you exactly what these here will do. As you can see, as I move the mouse around, I get control over these objects. That one's not doing anything. Now we will turn on this script. As with most people have seen, it's still not doing anything. However, this rigid body right here is still very important. Why? Because it's actually working. Problem is, it's asleep. Hitting it wakes it up. Stopping it, it goes back to sleep. And this is the problem everybody's been having with configurable joints in C# scripting. Give it a little nudge, and that wakes it back up. So how do we fix that? Well, this one here has actually got the script with the needed piece in it. As you can see, they move together. If I stop it, turn this one here off, turn this here back on, and you'll see that it moves together just nicely. So we're going to get this script to work just like this one. And this is the script right here. Go into Mono Develop, and here's the script. This is the piece of information that is missing. Right here we're calling in the rigid body, we're assigning it this name, and we're checking to see if the rigid body is sleeping. If it is, wake it up. Now we're going to build. Build assembly. Refresh. Go back to this game object. This is the one that was not working before, but with that change to the script, it's working just like the bottom one. That has been the problem all along. They fall asleep. You have to keep them awake. Now to show you what these two scripts, what all four of these scripts do. This script calls for the hinge joint, and I create a float that I control with the mouse with an update. From the hinge joint, I create a spring joint from the hinge joint. I apply the value that is changed from the mouse, and then reapply it to the hinge joint here. This does almost the same thing, only this is calling for the game object. I'm creating a hinge joint private, and from here within start I'm initializing the hinge joint to the game object, creating a hinge joint from the game object, and the rest of it is the same down here. This is the same as walk 1, only here we're calling for the configurable joint and the rigid body. This is why the rigid body was important, is because here, as I mentioned earlier, is where we wake it up when it falls asleep. Here I've created a vector 3 for our Euler angles that we will turn into a quaternion within this line here. And then from here we apply the quaternion to our target rotation in the configurable joint. This does the same thing, only here we're calling for the game object, just like in walk 2 we did with the hinge joint. Only here within start we're creating our configurable joint right here, or assigning the value of the configurable joint to this game object, and the same with the rigid body. Here is our section where we wake it up, and our section where we control the Euler angles with the mouse. Here's where we assign the Euler angle to the quaternion, and this is where we assign the value back to the configurable joint. And that's how it works. Working configurable joints.